All right, here's your lesson summary. Proportional relationships can be represented using the equation y equals kx. I know we didn't get too much detail on that, but if I use this table, here we go, k, so maybe this is not the best table, so I'll find one in a second and use that as an example. So let's actually move on from that. All right, let's look at this one. The ceilings in many basements are made of rectangular tiles. For one basement, each square meter requires 10.75 tiles. So if you think about a square meter, okay, a meter is the distance from the floor to a doorknob. Think about that. So think about this. Inside this, there are 10.75 tiles. 10 of these in here, in 1 square meter. So that they're giving you the unit rate, right? That's our unit rate, right here. Each square meter, so 1 square meter, right here. How many tiles do I need? 10.75. All right, and that's how I start filling the table. Now, our constant proportionality is this number right here. Right, this, which obviously 1 times what's 1075 is 10.75. So there is a constant proportionality. So my sentence would be, well, we already have it, but I'll write it anyway. For every 1 square meter, I need 10.75 tiles. So think about the tiles on the floor. So 1 tile, 2 tiles, 3 tiles, 4, 5, 6, 7, 8, 9, 10, and 0.75 on another one. So I don't need, it's not a full one, it's like 0.75, so it's a little bit less. Let's see if I can draw it better. There, a little bit less, right? 10.75. So now that I have that number, look how easy it is. What if I have 10 square meters? How many tiles do I need? Well, times 10.75, which means I'm going to need 107.5 tiles. Okay, 1 second. Unit rate makes life a million times easier. Okay, a million times easier. So now over here, it's a little bit different. It's the reverse. Well, something times 10.75 equals 53.75, right? So to find the number of square meters, well, I would do 53.75. I'm not going to multiply by 10.75, but in this case, I'm going to divide by 10.75. So if you take 53, and I think you already know the answer, 10.75, which gives us 5. Right, so 5 times 10.75 equals 53.75. So, and then the last one's a little weird. It says x. What if I have an x, what do you call it, square meters? Meaning it could be any number. It could be 5, 7, 8, 9, 10, 100. Right, for x represents any number of square meters. Well, whatever that number is, all I have to do is multiply it by 10.75. What's x times 10.75? And you know what? I should change this. Well, I'll change it later. So that would be 10.75x. Remember when we multiply a number with a variable, the number should come first and then the variable, right? I'll call the coefficient. This is the coefficient and then it's the variable. And know that they're being multiplied by each other, but if you don't see that little dot there, it's implied that they're being multiplied. Okay? Let's complete another table. All right, so these tables are done. Determine the constant proportionality that completes each equation. So your equation comes in this format. So hang on a second. Let's just complete an equation. So look at this over here. Let me try to write a sentence. To find P, right, which is this column over here, to find any number under the P column, to find P, I need to multiply S, which are all the numbers in this column, 2, the 3, by, and that's what we're trying to find out. So 2 times what is 8? Well, that makes it easier because it's a nice, easy number. But how would you find this? Times something, times something, times something. To find that constant proportionality, you need to divide 8 by 2. So if I divide 8 by 2, look, I get 4. If I divide 12 by 3, I get 4. If I divide 20 divided by 5, I get 4. If I divide 40 divided by 10, I get 4. Right, so our constant proportionality is 4. Is 2 times 4 8? Yes. 3 times 4 12. 5 times 4 is 20. 10 times 4 is 40. So to find P, which are the numbers on the right column, I need to multiply any number under the S by 4. And how do we represent using this in the equation? Well, here you go. To find P, I need to multiply all the numbers under the S column by 4. And that's how you would write it. That's an S, by the way. Here. Oh, and for the record here, not that they had one, but you can always add, what about 1? Well, there we go. 1 would be times 4, and that's our unit rate, right? Times 4. 1 times 4 is 4. So for every 1 S, right, how many P's do I need? I need 4 P's, and that's how I get it. So D and C, what's my constant proportionality? How do we find this number here? How do we find this number? Well, to find the number, pick any pair. Let's pick the first one. And you're going to divide 6.28 divided by 2. What do you get? 3.14. What if I divide 9.42 divided by 3? I get 3.14. What if I divide 15.7 by 5? I get 3.14. And the last one, 31 over 4, and then divide that by 10. I also get 3.14. So there is my constant proportionality. Notice it shows up over and over and over again. So this number is 3.14. Do you see the unit rate anywhere there? Well, let's create one there. Create one over here. So for every one, whatever the D represents, how many do I need? I need 3.14 of C's. So to find C, look at this. To find C, in order for me to find the numbers under column C, I need to take all these numbers here, right? So anything under the D and multiply it by 3.14. So there's my formula. And this here being the constant proportionality. While traveling into 2023, may receive 342.50 Norwegian kroner in exchange for 50 Australian dollars. How many Norwegian kroner would I have received in exchange for 1 Australian dollar? All right, so let's create a table. Okay, so what do we have here? Australian dollars. This is Australian, and this is Norwegian. So I'll write Norwegian. So I know right now, as they told me, that if I have how much? 50 Australian dollars, I'm going to get 342.50 Norwegian kroners. Question is, what if I have 1 Australian dollar? How much money will I get? How much Norwegian kroner will I get? Well, let's find out that number. That's our constant proportionality, that number right there. So let's find it. And how do I find that number? Well, I'm going to take 342.50, and we're going to divide it by 50. Which should give 6 something. 342.50 divided by 50. 6.85. So every one, so let me let me write that. 6.85 times 6.85. So if you have 1 Australian dollar, 1.1 times 6.85 is 6.85. So let me write that. For every 1 Australian dollar, I get 6.85 Norwegian kroners. And that's my unit rate. It's the unit rate and also my constant proportionality. So once I have that, look how easy it is, because let's say I took, I don't know, 85 Australian dollars. How much Norwegian money do I get? Well, that's not that hard to do anymore, right? Because I know the constant proportionality. So it's times 6.85. So if you take 85 times 6.85 and you get some value, I would get 582.25. What if I had 345 Australian dollars? Well, times 6.85, and I would get whatever I get. So see how having this makes life so much easier? Write an equation. So your equation comes in this format to get, N, to find out how much Norwegian money, and here's what that N represents, the Norwegian money, so I'll write Norwegian kroner. So in order to find out how much Norwegian kroner you're going to get, what do I have to do? I have to multiply 685 times A. What does the A stand for? Australian dollars. So this would be your formula. So determine the number of Norwegian krone my will receive in exchange for $120. Well, Australian dollars. So what? So here, Norwegian money, N, right? How much Norwegian money would you get with 120? Well, you're going to take 685, and you can multiply that by 120. 6.85 times 120, and how much Norwegian money will you get? You'll get 822 kroners. Right? So you're seeing a pattern here. So all you got to do is multiply by 685. So here's my formula, right? My relationship. Here, a plane flew at constant speed, so constant speed means the same speed, same rate of change between Denver and Chicago. It took the plane 1.5 hours to fly 950 miles. So we have a relationship here. And because that's the only relationship I know, that's the relationship I'm going to use to find the constant proportionality. So how do I find this number? Right? And the only place I can go to find that number is this. So what do? We go 915. We're going to take this column and then think about this x and y. So we have to take this column and we're going to divide it out by 1.5. So 915 divided by 1.5 is 610. So let me put that 610 right here. You just found your best friend. So it's going to be 610, 610, 610. It gets boring. 610. So where's our unit rate? Our unit rate is right here. 610, 1220. Okay, so let's 610 times 2.5, and you get 1525. And the last one, T, well, T represents now T for whatever amount of hours. So if I multiply T times 610, it's just 610 T. Unit rate, let's write that as a sentence. I know it didn't ask you. So it says, so based on this row right here, I can write for every 1 hour, for every hour, for every 1 hour, the plane travels 610 miles. That's complete the table. Check. How far would the plane fly in 10 hours? Well, let me put a 10 over here. So if 10 hours, what do I have to do? Just multiply it by 610. And 10 times 610 would be just 6,100 miles. It didn't ask you for the equation, so I'm going to add that. Where's the equation? All right, the equation is to find the distance. If I want to find the distance the plane flew, what do I have to do? I have to multiply the number of hours times 610. So I'm going to multiply 610 times hours. And how can I represent hours? I'm going to use the letter H. There. So if you tell me, hey, the plane flew 45 hours. Actually, no, I can't do that. The plane flew 21 hours. How many miles did it go? Well, put it in here. 610 times 21. The plane flew 19 hours. 610 times 19. The plane flew 22 hours. 22 hours times 610. Well, there you go. Bicycle travels 21 meters in 3 seconds. So, okay, so we have a little bit more. So again, think about this as your, right? So how do I find our beloved constant of proportionality? What is it? Times what? What's happening? Times what? Times what? Times what? Well, and again, I can only look here because I have both the time and the distance. This one I'm missing here and I'm missing here, so I can't use those two because I'm missing another number to find the relationship. But here I do. 3 and 21, I know you know, but I'm going to go through a process. To find this number, you're going to take 21 and you're going to divide it by 3. Start using or start writing that as a fraction, because as you saw in class, some of those numbers didn't divide. It divided, but you got a repeating number. So let's say you let's say you divide 2 over 3. You're going to get 0.666666666. But instead of using that or using 0.67, the repeating, right, I want you to use 2/3. So for this one, 21 divided by 3, we don't have to worry about because it's just 7. So what's the constant proportionality? It's 7. It's 7. It's 7. So let me add one more where the unit rate is. The unit rate has 1. But it's still times 7. So 1.5 times 7 is 10.5. Hi. Yeah. Somewhere on the desk. Wait. Let's just take it. Hang on a second. No. Thank you. So for this one, right, so we know it's times 7, times 7, times 7, but notice that this one, we're missing the something that multiplied times 7 that gives you 6 and 3/10. So this one, you're going to do it in reverse, right? So multiplying by 7, you're going to divide that by 7. If you have a calculator at home, so 6, you can do it manually. 3 over 10 divided by 7, and you get simplified, I can't see, 9 over 10. So 9 over 10, right? Because this equals 9 over 10. And if you don't believe it, let's see. 9 over 10 times 7. Well, put it over 1. 9 times 7 is 63. 10 times 1 is just 10. 10 goes to 63 10 times. 3 over 10 left over. Sorry, 6 times. 3 over 10 left over. So it works. All right, and then finally the last one, what's 1 times 7 is just 7. So where's my unit rate? Right here. So what's the statement? For every 1 second, 1 second, the distance traveled is 7 meters. Okay. Complete the table. Check what is the constant proportionality. Constant proportionality. And constant proportionality, by the way, is represented by the letter K. So constant proportionality is 7. What does this represent in this situation? It represents that which we just wrote. Reflection. You can do that yourselves. All right, that's it.